you? What does it suggest?
Well, hold on. Okay, so I feel like I understand a little bit about what you're asking, and my question is, can you describe to me what the y and the x axes are, so that I know that you that you have them straight in your head?
Okay, so the y-axis is the amount of radioactivity. So that's like the concentration of
Right.
the 32P, right?
Yeah, because what you're really asking about, the question you're asking, it kind of translates to why is there a normal distribution, and the answer is because a lot of the time you get a normal distribution.
Okay.
You know what I mean? Like, it's hard to answer this question because the only reason that you're seeing either an uptick or a downtick is you're talking about relative distance from the top of the tube, right? So for the most part, all of the DNA sequences that are the long pieces are going to fall here. That said, not everything is perfect and not every process is perfect. So in nature, a lot of the time, you're going to get a normal distribution. So some of them will actually be found, at different distances from the tube in either direction. Does that make sense?
If you wanted to cut out a certain piece of DNA, you want to make sure it's the right size.
Are you sure?
I think so.
If it doesn't, then it's totally fine. We
I
can come at it from a different angle.
think literally all you need to know is that at the beginning of DNA replication, there's a bunch of short pieces, and near the end, they're all good.
Well, that's true, but you also do need to be able to explain a little bit about how the graph works, because if she remember, she likes giving you wonky experiment results and asking you why it might have happened, So, it's good to be able to say what would we see if things were different. But the real answer here is what does this? Or are you talking about this one specifically? I guess I'm still confused. Are you talking about all of them, or are you talking about just some of them?
I'm just not sure what I'm looking at, in general. So I know, measuring the concentration and the bottom's measuring relative distance from the top. And then, the 60 seconds, that's just how long that they've been, or that's just, how long, I guess we're in there, and exposed to
The titanium bromide can't break up like you're saying. Does it have a chance of coming in and maybe that?
Oh, is it gonna still break things up afterwards?
Or just immediately once you add it to the sample?
I might still. Is it okay if I call one of the LAs over and see if maybe they'll have a better understanding of
Does the titanium bromide have a chance?
what's confusing you? Is that okay?
Yeah.
Okay,
What about
I'm gonna say what I'm hearing you ask, and then if I'm wrong, correct me, and we can take the next one.
make sure it's the right size.
The question I'm hearing is,
but you don't know.
why is it that we have a graph that looks like this distributed over the relative distance, as opposed to just discrete peaks at one particular spot? Is that what you're asking?
Yeah. Yeah.
And my best answer for that is that what you're seeing here is a general distribution of where these long pieces of DNA, which are the ones that have been labeled for 120 seconds versus the 60 second versus all of these, you're just seeing where they're generally distributed over the tube, over the length of the tube. And the reason that you're going to see more of a wider distribution than just the really discrete peak is just because that's kind of how nature works. You'll just see high results and low results in any experiment you run. That's the best explanation I can give, unless you have something.
Yeah, let me see what notes I have for this. I remember this. Let me look up exactly what she said.
These are the slides.
Yeah, but I remember I have notes from when I took the class, so I'm trying to see.
That's useful.
Yeah.
Because when you're talking about the times that these are being radio labeled, that corresponds with each line. This one has been labeled for longer than this one has been, so that doesn't actually have anything to do with the x-axis here.
So this is for thymine. Is this one specifically for thymine?
I'm not sure. She has one or two slides above that describe what